You see, you have static contact resistance, but you also have dynamic contact resistance. What it is? It is the possibility that we have to measure the resistance while the contact is opening. And this can be very, very important. We have had one instance of a circuit breaker on a ship that has had loose nuts, and because of that, the contact was absolutely unstable during the opening and closing. And this could be seen by the dynamic resistance measurement. I enter it, I select 200 amps and 1 milliamp range, then I selected it is A1. Now it is important, the contact is closed. Our capacitor is generating current only for a limited amount of time. So what we have to do now is to program the nominal operation time, that is 43 milliseconds, okay? Taking into account this, we will generate the current short before the actual opening, so that we are injecting current when the contact is actually opening. I can also connect, if I want, the transducer here, and I can have at the meanwhile the measurement of this opening and the measurement of the movement, and I do it. So, black, red, and blue. And here we are. Okay? So I check for transducer. Okay? Now it is ready. I can press start. Again, my capacitor being charged. And now let's have a look at what was recorded. It takes some time to elaborate because it has taken very many current measurements during this short time. Data processing. And here we are. You see, the diagram that you have here is, I would say, quite messy. But let's perform something. First of all, we zoom on what we see here, as usual. So this is the area of interest. What is it? You see actually 4 analog diagrams, of which one is the movement, and 1, 2, and 3 are current, voltage, and resistance. As they are too many, I would like to examine them one by one. How to do it? Go to View. You see, here you have checked the auxiliary 1 and 2 that are here below, no problem. But then, you see, you have also selected the voltage input for the transducer, then the voltage input for the voltage drop across the contact, and the current, and then here, unchecked for the moment, the million resistance. Okay? If I leave, I can see the first thing, that is the current that we have injected into the contact during the test. As I told you, you see, it is flat here. Okay? So we are actually injecting DC current. Now we change, I uncheck the current because we have already seen it, and I have checked the voltage drop that we are measuring here across these two clamps. Okay? And this is the voltage drop. Have a look. You see, there is a first portion of it that is quite short and it is smaller in amplitude, and then there is this situation of saturation. What does it mean? It means that we have injected the current, the contact was closed, this is the value of the voltage drop across my closed contact, and here, this part here is the most important one, because that's the part when the contact actually moved and during which we have performed the recording. But now, if we select, instead of this and this, if we select directly the milliohm measurement, here it is. Okay? Now again, I zoom it a little bit. Okay? So you can see it better. Given the fact that I have selected resistance, this is resistance, I repeat, contact resistance, resistance during the opening. And this is the important thing. Now, have a look. I select again this cursor. As I move the cursor, it is telling here, in terms of milliohm, the resistance that it is measuring. And look, 0.615, it is just the contact resistance that we had measured during the contact resistance test. You see? 0.61, 0.62, okay. So, during all this time, you see, from here it is now at 30 milliseconds. To here, well, I move it slow. That is 40 milliseconds. That is, during 10 milliseconds, we have injected the current into our contact that was still closed, no motion. Now, the interesting part is the following one. So let me see if I can zoom some more. Okay. And T1. Here it is, okay? The interesting part is this one, and as you can see, it is a linear resistance change from these few micro ohm actually, okay? Okay, 600 micro ohm, up and up and up, okay, until the contact was completely open. You see? You see? We are passing from micro ohm, well, to more than 1 milliohm, okay? But you can see that we have here 1, 2, 3, 4, 5 milliohm before the final opening. And this can be telling you that something is wrong or it is correct. Actually now it is correct. And the wrong situation is sudden losses, sudden changes of the contact. If you see it here, and then it is opening, that is going up, and then coming back, and then going up, gentlemen, have an intervention on your circuit breaker. Now, I will repeat the same test as before, but during the open instead of close. During the open, of course, the contact is open. By the way, excuse me, I have changing the setting 100 amps and 10 milliohm so that we can better measure the resistance variation along the curve. For the close test, I also have to input here the nominal close that was about 60. But now this parameter is not critical because until the contact is open, of course, there is no current generation. So we will anyway record the current only when the contact starts closing. Okay? Then I press start, that's it. Again, my battery, my capacitor being charged. It takes some time. Data processing. I'm showing you the time that it takes so that you are not concerned about the fact that the result is not displayed immediately. So it is normal. Take a breath. Okay, and here we are again. You see the result. Again, it can be quite messy, seeing that there are so many recordings altogether. Again, first of all, I move T2 close here, then I zoom a little bit, okay. Again, you see the movement, the current being injected, and the moment, and during this moment, we do have the transition from open, that it was before, to closed, that it is here. Okay, so I come again to view. I unselect the voltage, the 500 volts that is the transducer. I unselect the voltage, I unselect the current, and I select the micrometer measurement. Okay, so that we can study it immediately. And here we are. You see, that there is an open situation here. Then there is a transient, and this transient is due to the fact that because of the inductance of connecting cable, this cannot be eliminated, but then you have a value here of resistance that is no more open value. Now again, in order to ease the measurement, I move closer my cursors so that I zoom on what can be of interest. Okay, zoom again, and here we are. You see? So, I move again my cursor, and what do I read? Before my test, before the current actually started going through, there is no resistance measurement. Actually, it was open. Then there is this transient here. I move slowly. At the end of it, you may see that the resistance value is 0.697. That is, well, if I move furthermore, you see, it is stabilizing to the final contact. So, if I start from here and I go back, I can see the resistance slightly increasing, because as soon as the contact has been established, there was a higher resistance, and then, you see, milliohm, 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 and then that's okay. So, in conclusion, here again, if during the close I had some trembling because of plays caused by loose nuts or what was it, I would see it immediately. Okay? In conclusion, I can repeat my dynamic testing on all three phases, and thanks to this I am assured that there is nothing wrong on the movement mechanism.